Hey, chemistry, welcome back. We're going to talk about naming systems today. So, we have talked about a naming system so far. We've talked about how to name ionic compounds. So, I know it's right off the bat, but pause the video here and see if you can tell me what the general format for an ionic formula is, and then how we would name that formula. So the general format of an ionic formula, it's always going to be a metal, and then that metal will have some subscript, and then it will be a nonmetal. I'm going to make the nonmetal a Y just for fun, and then some subscript. So that's the general format of an ionic compound, and when we name an ionic compound, we always name the cation, which in this case is M, and then we name the anion, which in this case is Y. So that's the general formula of an ionic compound. That's the general formula of the name of an ionic compound. And like we talked about before, bases fall into this category because bases are just ionic compounds that include the ion hydroxide. So like NaOH or MgOH2 are both bases, and they are also both ionic compounds. So in both cases, we would name the anion, then the cation, sodium hydroxide. Anion, then cation, magnesium hydroxide. If we had one that included iron, we would name the cation, which in this case is iron 2, and then we would name the anion, hydroxide. So all ionic compounds are named like this. So the question is, do we need a covalent naming system, or can we just name our covalent compounds the same way we name ionic compounds? So let's take a look. First of all, take a look at these three compounds here. Tell me what type of bond you're going to find in these molecules. So this would be a good place to pause the video and see if you can figure out the type of bond. So carbon to oxygen in this one is going to be a covalent bond. In this one, we have carbon to oxygen, also a covalent bond. And in this one, we have carbon to oxygen, three times. Overall, it gets a charge, but the bonds inside are still covalent bonds. Okay, so now let's try to answer our other question. Can we name these three compounds using the ionic compound formula general name? Well, I'm so glad you asked. If we were to name this, we would have to name the cation and then the anion. So here's our first problem. This doesn't form cations usually. And inside this compound, it definitely doesn't form cations. Remember, the difference in electronegativity between carbon and oxygen isn't big enough for carbon to pull the electron off and form a cation with carbon, right? And so there's no cation present to name. That's problem number one. Problem number two is, even if we kind of modified it, let's pretend carbon's a cation. This would be carbon oxide. This one would be carbon oxide. And this one also would be carbon oxide. Okay, so here's our second problem. If we were to follow the naming system of ionic compounds, we would name all three of these things the same name, and when in fact they're totally different molecules and they all have completely different names. What if we use Roman numerals, you might ask? Well, remember, you only use Roman numerals for something that form more than one charge, and carbon doesn't do that. Carbon doesn't form multiple charges. And so we come to our conclusion. We need a covalent naming system. In order to name a covalent compound, you need a covalent naming system. So here is naming system number 2 that we're going to learn, the covalent naming system. It has some similarities with the ionic naming system. It also has some differences. So let's talk about what it is, and then we can talk about some of these similarities and differences. So in the covalent naming system, you are going to do a couple different things. First of all, you are going to name the elements that are present. Okay, second of all, you have to tell me how many of each element there are using a prefix. And then lastly, you're going to tack on I, D, E to the end of this. So as we dive into these, one of the big things we need to know are, what are those prefixes? So let's talk about the prefixes. So these prefixes follow a system, and the system comes from the Greek. So in this system, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca. And it goes on from here. You're probably not going to see anything greater than 10. You might see 12. 11 has a prefix, but nobody cares what it is. 12 is do, deca, and you're just not going to see beyond that. So those are really the prefixes that you need to know. So in general, when you name within the covalent naming system, you're going to say the prefix that tells you the number of elements, and then the element name, a prefix telling you the number of elements, then the element name, and then you're going to tack on the letter "ide," or the suffix "ide," which tells you it's a molecule or a compound, right? Now, there are a couple exceptions to this, but this is the general format. So if we were to name this within this naming system that we have here, we would put in the prefixes, since we only have 1 carbon and 1 oxygen, you would put in mono, carbon, mono, ox, ide. Just like in the ionic naming system, you're going to drop off the end of the element name and replace it with ide. So instead of being oxygenide, we take the end of the element off and just put ide, oxide. Okay, so here you may realize one of the first rules that kind of breaks our system. If I asked you what CO is as a molecule, you wouldn't tell me it's monocarbon monoxide. What would you tell me it is? You would tell me it's carbon monoxide, right? So notice that this prefix got dropped. Carbon monoxide, right? So here's one of our first rules for the exceptions, is that when you have one of the first element, you drop the prefix. Other than that, you keep prefixes. The only other exception we see is when we have double letters. So notice in this case, it's monoxide is how I've written it, but we don't say monoxide, we say monoxide. So since we have this double vowel here, we're going to drop one of them. So if you have a double vowel, usually one of them gets dropped. Unless the double vowel is a double I. Just like the term skiing keeps both I's, if you have triiodide, you're also going to keep both I's. And then that's it. That's the whole naming system. So prefix, element, ide. And then if you only have one of the first one, you drop the prefix. If you have a double vowel, you drop one of those unless you have a double I. And that's the whole system. So now let's go back and look at the three. We know that CO is carbon monoxide. So what is CO2? Go ahead and name that. And if you said carbon dioxide, you would be correct. That is when you call CO2 carbon dioxide, you're actually using the covalent naming system. Same thing with carbon monoxide. There's a bunch of examples of compounds we're already familiar with that we already know what the name is within the covalent naming system. We just had to use the general system, right? Okay, so a couple other ones that we can name. Why don't you go ahead and try to name this H2O and then try to name this CH4. So pause here and name those. Okay, so if we use our system, prefix, element, ide, H2O would be dihydrogen monoxide. Notice again, it's not monoxide, it's just monoxide. Dihydrogen monoxide. Now, do we call this dihydrogen monoxide? No, not usually. Usually we call this water. So notice here that our the name that we're familiar with is not actually from the covalent naming system. But since it's a covalent molecule, we can name it within the covalent system. What's this other one? This other one would be carbon tetrahydride. So notice we dropped the mono. It's not monocarbon. It's just carbon tetrahydride. Again, you might know of a name from another naming system for this molecule. If you saw CH4 and you would call that methane, that name is actually from a different naming system. It's from the organic molecule naming system, which you will learn in AP Chemistry when you take that with me. So again, it's a covalent molecule. We can name it within the covalent naming system, and we would name it carbon tetrahydride. Okay, so that is your overview of the covalent naming system. We're going to come back together and contrast that with the ionic naming system and then practice that a little bit until you get familiar with it as well. The really big thing on this system is you must first identify it as ionic or covalent before you choose the naming system to use. So that is your big step number one. You must do that before you choose a naming system. But then once you've done that, you just follow the naming system and we find a name for our molecules. So let me know what questions you have. I will see you in class.